Bismillahirrahmanirrahim. This is FSC Part 1 2018 Mathematics paper. Question number 2 was solved earlier. Now question number 3. Attempt any 8 parts. We know, students, this question is from Unit 5 to Unit 8. So first year mathematics Unit 5 to 8 past papers are being solved. This is first part. What is it? Resolve x square plus 1 by x square minus 1 and 2 partial fractions. How will we do? We will first decide whether it is proper or improper. We know it is improper because condition for improper is degree above and degree below are equal or degree above is greater. It is p of x by q of x form. Degree of p of x, q of x equal or of p of x greater. It will be improper. So this is improper without any doubt. X square plus 1 by x square minus 1 is improper. In case of improper, we first divide. So we write by division. By actual division, what is the division? X square plus 1 when is divided by x square minus 1. We multiply it by 1 and get x square minus 1, and then we can see that what we are left with this form. Now by divisibility algorithm, we can write this. Therefore we write x square plus 1 by x square minus 1. This was given and now it is equal to, answer is 1 plus remainder by dividend, x square minus 1. This is quotient, this is remainder, this is dividend, and this is equal to actual given form. Now we can name it 1. If we name it 1, then we can proceed with this structure, 2 by x square minus 1. This will be resolved. Only this part is considered and is resolved. We can write here, now we resolve 2 by x square minus 1. That is, this is the resolution process. We can write further it in form x plus 1, x minus 1, and then this is first linear factor. This is second linear factor. We associate with them these unknowns a, b. Now we will just leave it here and we'll proceed with these two left hand side and right hand side forms. We take LCM on right hand side. What that LCM is, obviously x plus 1, x minus 1, value with missing value in the denominator will appear in numerator. These two are in LCM. X minus 1 was missing here. Compared with LCM appears with numerator. Same thing here. Denominator is x minus 1, x plus 1 is missing compared with LCM. So that will appear with B. Basic LCM taking rule is followed. And then we can see, students, 2 is equal to a into x minus 1 plus b into x plus 1. If we keep this equal to 0, put x plus 1 equal to 0, implies x is equal to minus 1. This we substitute it in this equation. 2 on left hand side remains 2. This will be substituted in this form. X is minus 1, we can see it as minus 2. 2 is equal to a into minus 2. This minus 2 will divide this. A is equal to 2 by minus 2. So finally we can see a is equal to minus 1. It is very simple. A is equal to minus 1. One of the value is found. Now we substitute the other denominator value. Other unknown is b, its denominator is x minus 1. We keep it equal to 0. Then we get x equal to 1. We substitute in this equation. 2 is equal to, we can see it as, if it's substituted here, it will become 0. So will be ignored, and we will substitute it in this structure involving b. So if we substitute x equal to 1 here, 1 plus 1, it will become 2. This 2 will divide that 2, and we can see b is equal to 1. If we could name this static, this is static. So now we write static implies. What does static imply? Static has this left hand side 2 divided by x square minus 1 is equal to a. A is minus 1 by x plus 1 plus b, value of b is 1 by x minus 1. Static takes this form when a and b are known. These values are substituted here, so static is now in this form. Now this static will change this equation 1. So therefore we could have written here static implies, and therefore we can write equation 1 implies, where is 1? This is 1. X square plus 1 by x square minus 1. This was question, is not equal to. It is written 1 here. After that it is written plus. After that it is written 2 by x square minus 1. 2 by x square minus 1 is equal to these two. So we write instead of this, these two here. Minus 1 by x plus 1 plus 1 by x minus 1. This is answer, dear students, where we resolved this given structure into its partial fractions. This is answer. And unit 6, this is if y is equal to 1 plus x by 2 plus x square by 4 so on to infinity, show that x is equal to 2 times, show that x is equal to 2 times y minus 1 by y. It is easy to understand. So we begin with given. Solution begins y is equal to 1 plus x by 2 plus x square by 4 plus so on to infinity is, this we identify as infinite geometric series. This is infinite geometric series. Infinite geometric series. This right hand side is infinite geometric series whose a1 is 1. And in geometric series we have r. R is second term divided by first. X by 2 is second term divided by first term is 1. Obviously something is divided by 1 means that value x by 2. So it's quite easy to see. R is found, a1 is found. Now we can write y is equal to, instead of this entire series we can write its sum denoted by s infinity. And what is it equal to? a1 by 1 minus r. Y is equal to a1. We write a1, it is 1 divided by 1 minus r. R is x by 2. Now we will find value of x. Value of x is required. We will separate x. We will make it as subject, and that will be the answer can be found. And y into 1 minus x by 2. We take this denominator value on that side equal to 1. Now we can see y minus xy by 2 is equal to 1. Y multiplied by 1 is y. Y multiplied by x is xy by 2 is equal to 1. We are going to separate this x from here. So we take this xy by 2 on right hand side, it will be positive. This is y on this side. 1 on that side will be negative, obviously, equal to it is xy by 2, xy by 2. And now we can take y by 2 on this side. We can see that 2 is in division here will get multiplied, and y in numerator will appear in denominator. This is x equal to. This has been proved. Quite easy to see. 4. What is part 4? He says find n. Find n. From where? If np2 is equal to 30. We know it is from unit 7, and let's see how can we find n from here. np2 is equal to 30. If you know that np2, formula for npr is npr is equal to n factorial divided by n minus r factorial. So r is 2 this time. It will be n factorial divided by n minus r factorial is equal to 30. We know that this n factorial can be expanded 2 terms ahead, n minus 1, n minus 2 factorial divided by, it is already written, n minus 2 factorial. This is equal to 30. This will get cancelled, and now we can write it n minus 1. We know that, and definition of factorial, we know n is positive integer. So these two are consecutive positive integer. N is one positive integer. This is one smaller than that. So these two are consecutive positive integers. We can write this as product of two consecutive positive integers, 6, 5. So from here we can see that this n corresponds with 6. This is one smaller, corresponds with one smaller on right hand side. We can imply from here that n is equal to 6, or otherwise we have another way to solve it. How can we solve? From here onward we can make it a quadratic equation, n square minus n. We can make it n square minus n equal to 30 on the other side. N square minus n minus 30 equal to 0. Midterm can be broken. N square minus 6n plus 5n minus 30 equal to 0. So dear students, you can see that's factorized from n minus 6 and plus 5 equal to 0. We know that from here we will get n is equal to 6. This value will be rejected because value of n cannot be negative here. So this will be rejected. N is equal to 6 will be the value which we found here. Part number 5. What is it? We have to find n again. He says find n is fact. NC10 is equal to 12 multiplied by 11 by 2 factorial. This is the question, and we will search n. Where is n? How can we find it? Let us begin. It is NC10 is equal to 12, 11 by 2 factorial. Dear students, if we would like to convert then this in NCR form, this is NCR, this can also be converted. How can we convert? We multiply and divide by the number which is one smaller than this, by a factorial of a number which is one smaller than this. So this is NC10, 12, 11, one smaller is 10, its factorial is multiplied, and obviously this can be done only if we divide also. So 10 factorial, we multiply right hand side by 10 factorial, right? Multiply, divide by 10 factorial. So one thing we already know that these three are consecutive, 10, 11, 12. Greatest is 12. It becomes, these all are consecutive, so it will become 12 factorial. What it becomes? So if we remember this thing, that if I write 10 factorial here, then what is left? These three are combined. 10 factorial, 11, 12, they are combined in 12 factorial form. This 10 factorial I wrote here, this is 2 factorial. If this is n, this is r, according to formula of NCR. What is NCR formula? NCR is equal to n factorial divided by r factorial, n minus r factorial. This is n, this is r, this is difference of both. All are in factorial form, n factorial, r factorial, and this difference of these n and r factorial. So this is n, this is r. Here must be difference of these two, 12 minus 10 factorial. It becomes 2 factorial. This is 2 factorial. Look, dear students, these 10 factorial, 11 12. They will be combined as 12 factorial. No change in numerator. They can be written in this form. Obviously, this 10 factorial is written here. I wrote this 10 because I want to consider it as R, because this is R on left hand side. So this is R on right hand side. This is n factorial, R factorial. There must be difference of n and R according to formula here. So if I write difference of n and R, it becomes 2 factorial, which is here. 12 factorial numerator, 10 factorial this one, 2 factorial this one. So obviously, now this is NC10. N factorial, R factorial, n minus R factorial. It can also be written in NCR form. N is 12, R is 10. From here we conclude that n is equal to 12. This is very much obvious and answer. Probability definition. Definition is numerical evaluation of chance of occurrence of a particular event. Is called probability. Let A be event and P of A denotes its probability. Then definition given by Laplace is probability of A is n by m, where n is number of elements and event sample space and m is number of all possibilities. Number 7. What is number 7? If 5 and 8 are arithmetic means between A and B, then find AB. Find AB. So how can we find them? It is easy. Let us begin. What is given? The statement with if is given. 5 and 8 are AMs between A and B. What does this immediately imply? It implies 5 and 8 are arithmetic means they will be in the middle. 5, 8 are in the middle. Between A and B, AB will be at the end. We will write R in AP. This is due to definition of arithmetic mean. Those who are arithmetic means will be in the middle. Those whose arithmetic means these are will be at the end. And all together will make AP. So it means that 5 and 8 arithmetic means they will be in the middle. AB are the numbers whose arithmetic means these two are. So it means they will be in the end and all will make AP. What is AP? It is easy. We can now use the definition of AP or definition of arithmetic means again. You know that this implies 5 is arithmetic mean between A and 8. Every middle term is arithmetic mean between its n terms. So n terms are A and 8, 5 is arithmetic mean. So it can be found by adding extreme terms A and 8 and dividing by 2. We will get the middle term is 5. So from here, this multiplied by 5 will be 10, 8 will be subtracted, A is 2. Easy to find, right? This 8 is in the middle of 5 and B. So 8 is arithmetic means between 5 and B. Every middle term is arithmetic means between its n terms. So if we consider it as middle term, then it is arithmetic mean between 5 and B. Also we write 8 is AM between 5 and B. So it means if we add 5 and B and divide by 2, we get middle term is 8. From here we see that this 2 will multiply by it will be 16, 5 will be subtracted, so it will be 11. Hence, required numbers are 2 and 11. 12th term of harmonic progression, part number 8. Find 12th term of HP. What is this HP? 1 by 3. Find 12th term of HP. 1 by 3, 2 by 9, 1 by 6, so on. This is HP and we require its 12th term. Solution begins. 1 by 3, 2 by 9, 1 by 6, so on is HP without any doubt. This further implies 3, 9 by 2, 6, so on is AP. This is the definition of HP. Definition of HP is, if the terms of HP are inverted, we get AP. And this AP tells us its first term is 3. Common difference. In AP there exists common difference. We know already. 9 by 2 minus 3. What will it be? 2 LCM. 9 minus 6. It will become, obviously this is 1 and it will become 6. And further it becomes 3 by 2. This is common difference. Now we find 12th term of AP. And we will invert it to get 12th term of HP. So we write 12th term of AP. 12th term of AP is denoted by A12 and is equal to A1 plus 11D. A1 is 3. 11D, 3 by 2. What it will become? 3 multiplied by 2, 6. 6 plus 11 multiplied by 3, 33. It will be 39 by 2. It is 12th term of AP, remember this. Hence we finally write 12th term of HP, which is required, is inverted form of this, 2 by 39. So this is our answer. Next question is, in how many ways 4 keys be arranged on a circular ring? Number 9. In how many ways 4 keys be arranged on a circular ring? So we must know that arranging keys on circular key ring, it is flippable circular permutation case, because you can pick up that key ring in your hand and you can invert it, you can flip it. Obviously you can flip a coin, similar way you can flip a key ring also. We have 2 cases. N objects can be arranged in circle in n minus 1 factorial ways. This is for when the case is non-flippable. For non-flippable, n objects can be arranged in n minus 1 factorial ways. This is first fact about circular permutations. And n objects can be arranged in circle in 1 by 2 times n minus 1 factorial ways. This is the case for flippable circular permutations. Non-flippable are seating arrangement. Seating arrangements or any painting on the ground. are non-flippable. On the other hand, keyring, garland, necklace are flippable. So these facts must be kept in mind. So this is circular keyring. Circular keyring is flippable. So for flippable, this is the formula. So the solution of this question is number of keys 4. Number of keys 4. This is n. It can be written as n is equal to 4. Number of circular permutations, circular arrangements we can say. Circular arrangements are 1 by 2 n minus 1 factorial. 4 minus 1 factorial, it will be 3 factorial. 3 factorial is 6. 6 by 2. Answer is 3. Next, number 10 part. He says prove the formula for. Prove the formula. Which formula? 1 plus 3 plus 5 plus so on. 2n minus 1 is equal to n square for n is equal to 1, 2. It can be easily proved. Solution begins. Put n is equal to 1. So what is left hand side? 2 into 1 minus 1. This will become 2 minus 1, 1. If we see right hand side, what is it? Right hand side, n is 1. Substituted in right hand side, it will be 1. Clearly. Left hand side is equal to right hand side. So for 1 it is proved. For n is equal to 2. We add these two terms. First two terms are added. So left hand side is equal to 1 plus 3 is 4. And right hand side we just substitute. Number of terms added here. These are our 2 terms. So we will substitute 2 here. 2 square it is 4. So we can write clearly. Left hand side is equal to right hand side for n is equal to 2 also. Hence this result is proved for both n is equal to 1. Okay, next. Next he says find term involving x power 4 and expansion of 3 minus 2 x power 7. The solution begins with comparison of this with general form. We write as it is minus 2x. We write x prime here. Otherwise, the general form is a plus x raised to power n. If we compare these two, what is this? A has the value appearing here is equal to 3. Obviously, we can see x prime is equal to minus 2x. This is very easy and basic mathematical fact that when x is multiplied by minus 2, a new term, a new value generates that is represented by x prime. In general form it is n, in this particular form it is 7, so value of n is 7. General term in this expansion a plus x raised to power n is this tr plus 1. Any term of this is given by this formula tr plus 1 ncr a power n minus r x prime power r. So look at it, we keep r unknown and substitute other values. Tr plus 1, n is 7, r remains r, a power 3, 7 minus r, minus 2x power r, then tr plus 1, 7cr, 3 power, 7 minus r minus 2, we separate these two, minus 2 power r, x power r. Now we require, not this power of x, we require power of x 4, obviously according to question. So we want to write here, in place of r, we want to write power of x. X is 4. From here we conclude that r is equal to 4. So if we substitute r is equal to 4, it becomes 5. T5, r is replaced by 4, 7c4. 7 minus 4, it becomes, here r is replaced by 4, here r is replaced by 4. This is 7c4, 35. 3 power 3 is 27. Minus 2 power 16 is 4 is 16. X power 4. So multiplying these all together, we obtain 15, 120, x power 4. So in this expansion, fifth term is having x power 4 and it is 15, 120 and is fifth term. Okay. Next question is find the value of 1.03 power 1 by 3 to 3 decimal places. This question is from 8.3 exercise. This question is of binomial series. 1.03 power 1 by 3 can be written as 1 plus 0.3 power 1 by 3. The general expansion, binomial series expansion is 1 plus x raised to power n, 1 plus nx plus nn minus 1 by 2 factorial x square, nn minus 1 n minus 2 by 3 factorial x cube, so on. 1 plus 1 by 3, 0.3. Look at it, 1 plus n x, this is n, this is x, nx. Then we write n. Remember, this is n, this is n. N minus 1 by 2 factorial according to this, x square. This acts as x here, 0.3, it's square. N minus 1, n minus 2 by 3 factorial, x cube, so on. By evaluating these all values, this 1, this is 0.1, this is 0.01, this is 0.00166, so on, up to so on. So these all are added up. Obviously the other terms are not included here, so this is approximately equal to 1.092. It has some errors. As we evaluate this directly, it gives more accurate values because all other values are also included, which we haven't included here. We included just 1, 2, 3, 4 terms. It has in fact infinite terms. If we include 4 or 5 terms ahead more, we will obtain more accurate value. So this is approximate value.